Hello everyone, so today we are going to be learning about graphing linear inequalities. Alright, so before we get into actually graphing inequalities, we are going to remind ourselves about just graphing linear equations. And so, what are the slope and y-intercept of your equation y equals negative 1/3 x plus 2? So what's your slope? It's the number in front of our x. So in this case, it is going to be that negative 1/3. All right, and then what's your y-intercept? It's that positive 2. Good. Okay. And then we did some graphing inequalities yesterday. So let's graph the solution set for x is less than negative 3. So the first thing we need to do is to go ahead and do our numbers. So negative 3 goes in the middle, and then you can do negative 2 and negative 4. Okay? And since x is less than negative 3, it is going to be an open circle over negative 3, and it's all of the numbers less than negative 3. So our arrow is going to go that way. Okay? Alright, same thing with B. So first thing we need to do is our number line. So 25 goes in the middle, and 26, and 27. Okay? Alrighty, since there is this line underneath our inequality sign, that means that our circle above 25 is going to be closed. And since G is greater than 25, that means that it's going to be all the numbers greater than 25. For C, do our number line, negative 1, 0, negative 2. Since there's that line under our inequality, close circle. And then since P is less than, we're going to the left. And then our final example for this is 9. K is greater than 9. Since there's not a line underneath, it's going to be an open circle. And since K is greater than 9, it needs to include all of the numbers that are greater than 9. Those weren't too hard, right? All right. So then, using question 2, we need to name 3 solutions for the set for C. Okay, so this meant going to letter C. Since P is less than or equal to negative 1, we need to have 3 numbers that are less than or equal to negative 1. So one number might be negative 1 because P is less than or equal to negative 1. So that negative 1 is a solution. Okay, what's another number that is less than negative 1? Negative 2. All right, give me another one. I'm going to go with negative 3 because I like to keep things simple. But you can do any number that is less than negative 1. All right. For D, using question 2, is 9 in the solution set for D? So here. So is 9 greater than 9? And then why or why not? And you should say, no, it's not included. Okay, and the reason is because it's not included, because there is no line underneath. The line underneath means included. So if there is no line, that just means it's not included. Okay? Alrighty, so now we need to talk about lines when we are actually graphing. Okay? So when we talk about our lines, if we have a greater than or less than sign, these are graphed using a dashed line. Okay? So a dashed line is something that looks like this. And it is comparable to an open circle. Okay? So because there is no line underneath, if you graphed it over here, it would be an open circle. Or when we start to graph linear inequalities, it's going to be a dashed line. Okay? Now, if we have greater than or equal to or less than or equal to, these are graphed using a solid line. Actually, let me also put some arrows up there. That way you guys know I'm talking about lines. Okay. And this is comparable to our closed circle. So like up here, when it was p is less than or equal to -1, because of that or equal to, it was a closed circle, and it's going to be a solid line. Okay? Alrighty. For shading, pick a test point, meaning any ordered point that is not on your line. Plug this point into your original equation. If the answer is a true statement, then shade including this point. If the answer is not true, like in question D, how 9 was not included, then you would shade in the opposite. Or opposite of the line. Or opposite the line of this point, sorry. I was trying to think of how to word it. Okay, and this paragraph will make a lot more sense when I do an example. Okay, so after I do an example, I'm going to reread this. That way, hopefully, it will make a little bit more sense. Okay? Alrighty. And your solution sets. These are all of the points in your shaded area. And they are included in your solution set. All points not in the shaded area are, you guessed it, they're not included. Alright, note that when graphing a greater than or equal to or less than or equal to, points on the line are included in the solution set. Okay, so just to make everything absolutely explicit, so when graphing, yes, you will want to write this down. Greater than and less than points on the line are not included in the solution set. Okay? All right. So now let's try our first example. Okay, our first example. We're going to take this nice and slow, or at least hopefully nice and slow for you guys. So first thing, this is y is greater than 2x minus 4. So for a moment, we are going to ignore this sign. Okay, we're going to ignore it. Just think of it like it's an equal sign, because you guys are good with graphing with equal signs, okay? So what's your slope? It's 2. What's your y-intercept? negative 4. Okay? Alrighty. So now, talk to me about what type of line is it. Is it going to be, is it going to be a dashed or a solid line? It's going to be a dashed line because there is no or equal to line underneath. Okay? Alrighty. So, we are going to go ahead and graph this line. So you start at your y-intercept of negative 4, and you have your slope of 2. So we're going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Okay? Now when we graph it, remember it is a dashed line. So we have to make dashes. And don't forget your arrows. Okay? Alrighty. So when we are talking about y is greater than this equation, we're talking about our y values. Okay? So if my y is greater than the line or less than the line, okay? So is this negative 5, is it above the line or below the line? Because this is above the line, this is below the line. So is it above or below? It's below the line, okay? You all see that? Alrighty. Well, this says that y is greater than the line. So what do you think greater than would be? Would it be above the line or below the line? I'm hoping you said above the line because anything above is greater than, okay? So when we shade, we are going to shade above the line. And you are actually going to shade, but you can just make these little dash marks like I am, okay? And just to make absolutely certain that you guys can see it on here, there we go, okay? So anything in our shaded area is going to be a solution set, okay? So pick somewhere in your shaded area. Where's a solution? How about right here? Our origin. Our origin is a solution. So you would write 0, 0. Okay, what's another one? How about right here? That's a solution. So you go negative 3, positive 3. Okay, so any point in the green is a solution set. Okay? And I did the test point of 0, negative 5, which was not included. Okay? I always use test points on my y-axis because it makes more sense to me. If picking a random point makes more sense to you, go for it. Okay? But just make sure that it is actually included in your solution set. Okay? Alrighty. Now we're going to move to the back. We're going to try another one, and we're going to take it slow again. Okay. Alright, so for number 2, y is less than negative 2/3 x plus 2. So what is my slope? My slope is negative 2/3, or negative 2 over 3. What is my y-intercept? It's 2. Good. Okay. So now I'm going to go ahead and make my points. So y-intercept of 2, and then I go down 2, 1, 2, and then to the right 3, 1, 2, 3. Because remember, your negative only goes with one of these numbers. So 1, 2, 1, 2, uh-oh, that's out of there, okay? So now I'm going to have the negative go with my 3, so I'm going to go up 2, 1, 2, and to the left 3, 1, 2, 3. If you're not convinced that this works, start at your leftmost point. I go down 2, 1, 2, and to the right 3, 1, 2, 3. See? It works. All right, what type of line is it going to be? Is it going to be solid or dashed? Well, let's take a look. Over here, you had to have, there's no line underneath other than the line where I wrote it, but that's not included, right? So it's going to be a dash line. Well, that's not what we have here. We have the line underneath. So for the line underneath, it's a solid line, okay? So flipping back over. So it's going to be a solid, mostly straight line. Okay, so this is solid. Okay? Alrighty, so now we need to do a test point. I am going to pick the test point of, let's do positive 4. Okay? So my test point is 0, positive 4. Right there. Okay, so this is saying that y is less than or equal to my line. Well, is 4 above my line or below my line? It's above my line, right? Like 4 is above this line. So that means that 4 is not included in this set. Therefore, let's take a look below my line, okay? And 2 is below my line because it's y is less than my line. So when we're talking about less than, it needs to be below my line. So we are going to shade everywhere below our line. Okay? Alrighty. So I'm going to read that paragraph again. So for shading, pick a test point. Any ordered pair that is not on our line. That's what we did. We did a test point of 4. Okay? Or 0, 4. Plug this into the original equation. You don't necessarily have to do this, but we certainly can. Okay? And honestly, this is the real reason why I choose numbers that are on the y-axis. Okay? So we're going to plug it in like it told us to, just to make sure that you guys understand what I'm talking about. So, y is less than or equal to, oops, sorry. So, since it's 0, 4, this is my x, this is my y. So, 4 is less than or equal to negative 2/3 times 0 plus 2. Okay? Alright, well, negative 2/3 times 0 gives me 0. So, is 4 less than or equal to 2? No. So our test fails, which is why if the answer is an untrue statement, then shade opposite of the line of this point. So our test point, was up here. Since this was an untrue statement, we shade on the opposite side. Okay? That's just another way to look at it. If that way confuses you and the other way made sense, go with the way that I'm going to continue to use. Otherwise, you can use that way. It is completely up to you. So now, 2 points that are not in the solution set. Well, our test point wasn't, so we can say 0, 4. And we can also say this point right here, which is 5, 3. 5, 3 are not in our solution set. Okay? Alrighty, we're going to try another one. There we go. Okay. Y is greater than or equal to negative 2. Okay. Do I have a slope? No. So what is my slope? It's 0. because we could say plus 0x. Because remember, our slope is always the number in front of our x, and 0 times x gives us 0, which is why it's just y is greater than or equal to negative 2. So our y-intercept is negative 2. So we can go ahead and we can graph negative 2. Okay? Now, real quick, is this line horizontal or vertical? It's horizontal. Okay? All right, now, what type of line do we have? Well, let's look at the top one. So, the top one had a line underneath, and it was a solid line. Therefore, there is a line underneath. It is a solid line. So since it's horizontal and a solid line, just going to graph it just like that. Okay? Now, since y is greater than or equal to negative 2, we need to pick our test point. So I'm going to pick a test point of 3, because why not? Okay, so 0, 3. Now, is 3 greater than negative 2? Absolutely it is. Okay, so since 3 is greater than negative 2, we are going to shade everywhere above our line. Everywhere. Okay? Alright. Now our question over here wants a specific point. So it wants to know if 3, negative 4 is in the solution. Well, we have to go over to 3. I know I shaded it kind of heavy, so it's kind of hard to see, but this is 3. And then we go down to negative 4. Alright. So this is not in our solution set. So we would say no. Okay, but why? Why is this not in our solution set? Because it's not in the shaded area. That's simple. It's not in the shaded area. Okay? Alright, next example. Y equals negative 2x. So what's my slope? It's negative 2. What's my y-intercept? Does that help you? Cool. Then it's 0. Okay? So we start at 0, and we go down 2, and to the right 1. So down 2 to the right 1. And then up 2 to left 1, up 2 to left 1. Okay? Alright. Now, what's different about this one? Is it a solid or dashed? Well, hopefully you said solid, because we have an equal sign. Okay? So, solid line. Alright, now we're going to go ahead and go over to our question. Did you have to shade above or below the line? Do you have to? No, you don't. Why? Because our equation is not an equality. We only shade linear inequalities. All right. That That one was tricky. It was trying to get you, but hopefully you guys were smart enough to recognize that, okay? Alrighty, moving on. Also, what's the difference between an inequality and an equation? One has an equal sign, which is our equation. One has a greater than, less than, or equal to sign, which is an inequality. Okay? Alrighty. Last one before you guys get to go on to Delta Math and continue your work there. Okay? Alrighty. So, for example 5, what is my slope? It is 2/3. What's my y-intercept? -3. Okay, what type of line do I have? Solid or dashed? This time it's going to be dashed because there's no line underneath. Okay, so we're going to go ahead and graph. So start at -3, go up 2, to the right 3. And now I'm going to go down 2 and to the left 3. If you don't believe me, start at that point, go up 2 to the right 3, and that's our slope. And since it is dashed, we make dashes, but we still have to include our arrows. Alrighty, what do you want to use as your test point? Let's use the origin. Okay? Alright, so our test point is 0, 0. So, is 0 above or below our line? It's above our line. Okay, cool. So, y is greater than. Since y is greater than, we want it above our line because y is greater than our line. So, we want it above. Awesome. So, now we can shade above our line. Yay. Alright, now we have to look at our test point. 3, -1. Or sorry, is the point 3, -1 in our solution? So go to 3, -1, and that's right here. Okay? So is this in our solution? It's on the line, yes, but remember, it's a dashed line. And we have to think of our dashed lines as an open circle. Are open circles included? No. So this is not in the solution because we have a dashed line. Alrighty. We have just completed our notes for today, so please start working on Delta Math linear inequalities. Please remember that it is due Friday. If you have any questions, please raise your hand.